When it comes to using the terminal, a lot of people get confused when to use quotes, when quotes are necessary, why their command isn't working the way they want to, why I sometimes have to escape spaces for certain commands and why I don't have to. If you find yourself randomly throwing backslashes in there and double quotes and single quotes, and you kind of have an idea of what they mean, but you don't really understand, I'm going to demystify as much of that as I possibly can today. Now, every terminal is going to be different. Okay, when I say the terminal, I'm talking about like Unix or Linux. In this case, I'm running on my Mac, but it'll be the same as like a Linux terminal or whatever. Your shell is the program that runs that terminal. So for me, I use bash. I'm going to be talking about bash today. You might be on Z shell, you might be on fish, you might be on new shell, you might be on C shell, you might be on a POSIX shell. You might be one of those people in my audience who's like, Dave, I actually wrote my own shell and it's not POSIX compliant. I do whatever I want. Yo, more power to you. This video is probably not for you. You probably know what you're doing. But if you want to learn and you want to follow along with this fun little quoting adventure and all the mishaps you can get into, yeah, I'm going to do my best to demystify it for you today. So let's jump into it. So to get started, I created a directory just to work out of today called temp quotes. It's just a directory here, nothing fancy going on. There should be nothing in it. Let's ls it, and there is something in this directory. Look at this. We have a file. Not only do we have a file, it's a directory. It's a folder, and the folder name is, look at that. That's a tilde character, isn't it? The slash is because my ls shows it. If I were to echo star, this is in my current directory. If I were to do a long listing, we can see that we have this directory here, and it's named tilde. So what do we do about it? Do we just run something like rm-rf tilde? Don't run this. Do not run this. Beep, beep, warning. Take a beep, beep. It's too early in the video to be this dumb. Take a look at this. I put this in front of it just so I wouldn't accidentally run it because this would be a comment to bash. Okay, do not run this command. This is dangerous. But if you watch this, you're like, Dave, it's not really that dangerous. Let me just put quotes around it and this will work. Will it? You sure about this? You might have been confident when you said it, but now when it's written out, do you really feel confident? It might work. I'm not telling you that it won't work. I'm just saying, how confident are you on pressing enter on a command that looks like this? I know the shell pretty well. I'm a little bit scared running this command, okay? Because there might be some other stuff in play. Some read line or line editing interfaces might actually be doing some sort of expansion. You should always be careful with this. So instead of explaining all of this first, I'm actually just going to show you how to test it easily and give you a practical example of this, okay? You wanted a simple video on quoting. You're not getting a simple video. We don't do simple videos here, okay? We're going to make a C program. We're going to code some C today. args.c. Make a new C program. Int main. We will take argc, which is an integer, and we will take a pointer to character data or a pointer to strings, which will be terminated with a null pointer. Super nice. Thank you, C, for making such a nice main function for me. Called argv. This is our argument vector. And there we go. Let's go ahead and explicitly return 0 there, even though we technically don't need it. And now we have a program that can get arguments. We don't do anything with them, but we have the arguments. So now that we're here, we can printf got %d arguments new line, and we will give it the argc. So we'll print out how many arguments you got. If we want to use printf, we have to include standard io.h. Very simple. Now that we're down here, we should loop over the arguments and print them out to the user. So let's do a for int I equals 0, I less than argc, I plus plus. I just used double parentheses because I've been writing so much bash. Wow, that was automatic. That was incredible to see. Don't use double parentheses, use a single parenthesis. Now we can printf arg %d colon %s new line, and we will give it argv at spot I. There you go. Now we have a simple C program that will print out our arguments for us so we can see exactly what's going on. Ready for this? We'll cc args.c into args. Oh, wow. Thank you so much for the warnings. I totally forgot the argument here. What was I thinking? You got to print the I here. Wow. Thank you. Thank you, C compiler. There we go. Beautiful. Oof. Let's go ahead and run args on its own. We have one argument, and the argument is ./args. This might be a little confusing to people who haven't seen this. If you're dealing with other programming languages, you might have expected 0 arguments, and you're like, why are you getting the name of the program as the argument? Well, it kind of is the name of the program. In this example, it is the name of the program because bash is running args with an argv0 of this name right here, this literal string of a dot, a slash, and an args. It's a little bit confusing if you've never seen it, but your program actually does get the name of itself as its 0th argument. This is how a program like BusyBox can be executed with the name ls and run like ls, or be executed with the name awk and run as a very limited version of like awk. It's by inspecting the argv0. We can modify this with bash. What I'm about to write is a little bit scary, and probably I'm just going to cut this from the video because it's a little bit too much, but if you make a parenthesis here, but if we open up a parenthesis here, we've created a subshell. Now that we're in a subshell, we can run exec with args here, and we will get the exact same thing, and now we can give it a -a of foo, and it will run with this argument of foo. Very confusing, super side tangent aside. Dave, cut this from the video. It's going to confuse people. So anyways, yeah, we run args on its own, we get one argument and this. What we're going to do for the sake of this video is let's go ahead and filter that out, okay? There's a lot of ways we can do this. Instead of printing argc here, we can just do argc -1, and we could set I to 1 here. And then if we recompile it and we run it, we can see that we got 0 arguments. That's great. We could run it with foo. We got 1 argument. arg1 is foo. I like this way of doing it because I do think of this as argument 1, because 0 in my brain I think of as the name of the program. So I like this way of accomplishing it. I've seen other people do something like this. They'll do like argc --, argv++. So this will just subtract 1 from the argument count, and it will move the argument vector over 1, so it'll just kind of filter it out. I've definitely seen code like that. We don't want to do that. We also do want to show 1 instead of 0. So I like it the way I've written it. We run this, and we can see that we got 1 argument, foo. If we run foo bar baz, what do you think we're going to get? 3 arguments, foo bar baz. Hey, that's super cool. With this program, we can answer a lot of questions now. So remember before when I said, well, how do we get rid of that file? We have this file that's here in our, like, what do we do about it? Well, you might be afraid to run RM, and that's totally cool. That's smart. You should be, okay? Instead of running the RM command, you could run args, and we could imagine what the RM command would look like. Instead of running RM, we could say args-rf tilde. And if we run this, we can see how RM would have been executed. You could also put an RM here, which will show you exactly what will be executed. It's safe to run, but I don't want to get you guys in the habit of writing RM-rf just willy-nilly, so I'm not actually going to run this. I want to be a good example here. If we run RM with this, we will get -rf, and then we will get my home directory. That is not what you want. You want to find a way to escape this tilde. So if we put quotes around it, it works. We safely escape the tilde. RM doesn't do any special processing on this, so it will get a literal tilde character. This is good. It solves the problem. But with our program, we can make damn sure that's what's going on. I think that's important. Double quotes also prevent that expansion. That's super nice. // for our current directory. This also does work. So these are different ways of removing this. Still scared? So am I. Put single quotes around it, and it looks like it still works. This is exactly the string that's going in there. Notice we're giving it quotes, and the C program is not giving those quotes. That's because bash is removing the quotes. Some people get confused by this. They're like, oh yeah, RM just gets rid of the quotes. No. RM would see a literal quote. The shell's job is to remove quotes, and that's part of what it does as part of its rules of parsing. So with this, we should be safe to run this. Now, when you're in this situation, guys, there's a lot of other things you can do. Let's go ahead and ls that directory. There's nothing in there. There's nothing in this directory. I made it an empty directory. There's nothing in there. Let's be as safe as possible. Because it's an empty directory, we can run rm-dir. There you go. It's gone. Safe. That's simple. That's how you do it. But again, this arguments command, totally useful, super useful for you to understand what's going on. Because if I were to print something like a equals, this is just a variable I'm making in bash. Hello world, comma, space, how are you? This is a string by $user, and then we close it, right? If we echo $a like this, notice what we get. Notice we've lost the extra spaces here. Isn't that kind of weird? Why is that? Before I explain why that is, let's just pass it to args. Args $a. So in our example up here, echo would be run with the arguments hello, world, comma, how are you? This is a string by literal $user. Echo got 11 arguments here, and echo by default will separate them by spaces and emit a new line at the end. That's what happened here. It lost this because this variable was unquoted, and bash did something called word splitting. Other shells do this too, but that's what happened here. This underwent word splitting. It underwent some other stuff too, but word splitting is the big one here. If you want to avoid word splitting, put it in double quotes. We'll still expand variables, but if you put in double quotes, look, we only got one argument and it was the literal string. That's what we want here. If you were to put single quotes, we will prevent expansions, and args will only get called with $A. Now, if you notice above where we set the A variable here, I have $user in here, but because we're using single quotes, we're not getting expansions. So let's go ahead and swap these out for double quotes. I'll put this up here so you guys can see it. And let's rerun args with $A like this. Look, we have Dave down here, but it still lost all that white space. So it underwent word splitting, but this variable was expanded at the time of variable assignment. So pretty cool stuff. Again, put double quotes around it. If you just want this to show up, we'll still have Dave there, but it shows up exactly how it was written. Super cool, super useful. Single quotes, again, if you just want the literal $A. This comes in handy. This comes in very handy if I want to give a directory that has spaces in it. Okay, let me show you guys something. Let's just do a file. Let's make a file that has space in it. Touch, I'm using quotes here. This file has spaces, lol.txt. Okay, if we ls, we can see this file has spaces, lol. That makes sense. If we run args with this, and I'm gonna hit tab. Notice what tab complete there did there. It put a bunch of backspaces and spaces there. This is fine. This is escaping this space from the perspective of bash. It's telling bash, oh no, this is still part of the same word. So when I run args, look at this. Our C program didn't get those backslashes. It got literal spaces as one argument. That is very good. That is what you want. If we didn't have these spaces here, you would get this. And if you were to try and RM this, RM would go through and RM a file with these names. All of these files, if they existed, would be deleted. That's why it's so scary. When you're passing things to RM, make sure you've escaped the right things, or you can do this. You just put single quotes around it. Actually, in this example, there is going to be a stray space here, so it probably won't actually be able to delete that file because of that stray space. So get rid of that. That's how that works. Hopefully that makes sense. But yeah, when you don't quote your variables, you will get some weirdness from it. Bash does also have special strings, so you can do this. And I can say like hi here, and look, it gets the literal hi. But I can put escapes here, so I could say like hi, new line, bye, and it will actually put the literal new line in there. So even though I see a \n here, when it gets passed to the C program, it gets the actual literal new line here. This is super useful. I've used this to escape color, so I could say like 31M red, and then we can close that with an escape of 0M. So if you run this, you can see that it got this with red. It actually got the literal escape sequence as its argument. So definitely something to be aware of, and something that's really cool, because I could save this as a variable. We could say like red equals this, and then I could run .args with red. And as you can see, we didn't have to quote it. You should always quote your expansions, but I'm just showing that we didn't need to. The literal escape sequence was in that variable. We didn't have to do anything fancy to get it to turn into red. I'm gonna give you guys a light mode jump scare. 3, 2, 1. Shout out to the Wooledge Wiki. This is where I've learned almost all of my bash knowledge. It was super helpful when I was learning bash. But there's this awesome section about the bash parser. When it comes to turning a command into what you see on the shell, into what gets executed, there's a whole bunch of stuff that happens. We have to read the input. You have to process the quote, so it figures out when single quotes matter, when the backslash escapes matter, when all that stuff matters. We have to split the data into separate commands. You have to parse the special operators, because bash has all this stuff, you know, curly brace expansion, subshells, things like this. You have to actually perform the expansions, which is like the $$PWD. You have the globs like star.txt. Then you have to split the command into command name and arguments. Then you have to execute it, so like running execve or whatever. And there's also like quote removal that goes on in there. There's a whole order of operations like parameter expansion, variable expansion, process substitution, command substitution. It's all on the bash man page. You can all find it here on this. I'll have this link in the description. But it is super useful to know. But remember, the quotes do get removed. A lot of people get tripped up on that. In fact, I could show a couple more examples. Before, I think I did echo star, and this just prints all the files to the screen. If I run args here and give it star, look, we have all the files here, but look, it's not broken on spaces. Every single file is a separate argument. So bash handles separating the files for you. It's super nice. If I give it this, it was only called with one argument, which was this name. Even though the name is super weird, it was only called with one argument. Super useful to see it this way. Likewise, if we were to use command substitution, we could say like run uname minus a here. Actually, I'll just show you guys what this looks like first. If I run uname minus a, we get a whole bunch of stuff about my computer. If we were to pass this to args exactly as is, we have two strings, uname minus a. If we pass it like this, what do you think is going to happen? Look how many arguments args was given. Every single one was given as a separate argument. You can quote these though. Of course you can quote these. And now look, it was only passed as one argument, one big giant unmodified string. Technically the new line was removed. That's part of the command substitution, but that's basically what's going on here. What you see is what you get minus that trailing new line if it's present. There is also process substitution. You may have seen this syntax. This is going to be weird if you've never seen it. Get ready for this. It just gives you a file descriptor number, dev, fd, and then this file descriptor number because you're supposed to read from it, not print to the screen. So you would actually pass this to something like cat if you wanted to get the output that way. But this arguments command, hopefully this is useful for you guys to see like, oh, if you have a command like this, instead of having to run your command where you're not sure how the arguments are going to parse, you can just run to this argument command and see exactly how bash or whatever shell you're in is breaking things apart. Super useful to see. I totally just thought about this. I'm going to throw this in the video. Imagine we had a file called like data.txt where we have foo, bar, baz, bat. And if we cat data.txt, we have these 4 lines. Okay. Well, the nice thing is you ever like pipe this to xargs echo? And now look, we have foo, bar, baz, bat. It ran echo and then something. Well, instead of running echo, we can just give it args. And we can see that args was run once and it was given these 4 arguments. And that's because xargs is kind of smart about how it passes standard in over to the program. It's very efficient by default. We can override this. We can say -n1. We only want one argument given to a process. So then we can see that it was executed 4 times. Each time it was executed was given one argument. It was executed with foo, it was executed with bar, it was executed with baz, it was executed with bat. So this is a cool way of visualizing that. We could change this to 2, and we can see that it was executed twice with foo bar and baz bat. So xargs broke it up. You can also give it 3 here. What do you guys think is going to happen? That's right. It was executed with 3, and then it was only executed with 1 because that was all that's left. So it's super cool to be able to see it this way. You can kind of get an idea of what xargs is doing on your behalf. Having a command like this in your back pocket, super useful. Light mode jump scare again, I'm so sorry. But again, shout out to the Wooledge Wiki. They have this little POSIX script here, which is absolutely super useful. I've used it to learn. It's super useful. I'm actually just gonna show you guys this because that's how awesome it is. Let's call this args.sh. We're gonna need better names for this, aren't we? So we'll just copy this exactly because this is just a POSIX script. It's not a bash script, POSIX script, but it will just work. So we can just do args.sh. So if we run args.sh, foo bar baz, we can see that we have 3 args, foo, bar, baz. If we run it with nothing, we get nothing. That is super cool. Again, very simple script, very helpful. You can use something like this when you're debugging. You don't need to download the C program and compile it if you feel like that's a little bit too heavyweight. Go to that Wooledge Wiki, pull down this. It's 3 lines, and you can run it, and it will work all the same. So if I give it like uname minus R here, no, I gave it -A. It got 15 arguments. If we run, oh wait, that's our C program. Hold on, I'm lying to you. If we run our C program, we get 15 arguments. Obviously, you can change the style and how it outputs it. But yeah, this is just a super cool way to see it. Super easy. If you're running any sort of Unix or Unix-like operating system, you're going to have the POSIX shell. So this will just execute. It will work. It's a super simple program, but it is like infinitely useful. It helped me so much when I was learning. But yeah, that's all I got. Hopefully that demystified it a little bit for you guys. I know it can be a little bit confusing. There's a lot of stuff that goes into the parser, but with this little tool under your belt, the little args command, hopefully this can help you and get you out of sticky situations. With that, I want to give a shout out to my patrons over at Patreon. Thank you so much for your continued support. If you want your name at the end of one of my videos, go ahead and check out my Patreon. Sign up for it. Get your name at the end. And look at this. You can break my output script if you can figure out how to put ANSI escape sequences in your name. A lot of my audience likes to break my script. I think it's hilarious. It's awesome. No one's done anything nefarious yet, so I just let it stay in there. Who cares? This is awesome. So yeah, that's all I got for you guys. Hopefully this is interesting. Let me know what you guys think about this kind of video, these smaller little dives into things. So I know I can make long-winded videos. I make multi-hour long videos, and some people are like, Dave, it's a little bit too much. So every so often I want to switch it up and just throw you guys like a smaller, like, 10, 15, 20-minute video. So yeah, let me know what you guys think. Thank you so much. Hit that subscribe button if you're not subscribed. That's crazy. And yeah, that's all I got for you guys. See ya. Take care.